Hello, everybody. Happy Friday and welcome to TGI Kubernetes. I am your host, Joe Beda. For those not in the know, TGI Kubernetes is a weekly-ish live stream that we do where we explore all sorts of things in the Kubernetes space. Sometimes we go deep on stuff happening in the community. Sometimes we play with new projects. Sometimes we know a lot about what we're talking about. Sometimes we don't know quite so much. This week, we're going to be digging into the combination of Pulumi and Kubernetes through the lens of this project that is relatively new from Pulumi called the Pulumi Kubernetes Operator. And in doing so, I am lucky to have some great guests joining me from Pulumi, and I'm going to introduce them here in order. So first we have Joe Duffy, who is, Joe, you're CEO of Pulumi, right? I don't know, founder and CEO, is that right?
I am. I used to be a developer, but I guess I have to go with the CEO label now.
Yeah, let me get Vivek and Lee on board here too. And then we have Vivek and Lee. And so, yeah, let's do some quick introductions of y'all. Why don't you start, Joe, and let people know who you are?
So thanks for having me. I'm the other Joe, Joe Duffy. So I founded Pulumi actually coming up on 5 years ago, which is absolutely mind-blowing. Previously lived life as, working on developer platforms and got to know Joe Beda around the time we were starting Pulumi, actually, around the same time you started.
Yeah, we wanted you to come join us at Heptio, but you had other ideas.
I know. So those were the days, hanging out, brainstorming about startups. But yeah, 5 years later, it's been fantastic. So happy to be here.
All right. Lee, why don't you go next since you're sort of next in reading order here?
Absolutely. Yeah. Lee Briggs, I've been here at Pulumi now, I think it's coming up to 2 years. I've done a variety of things here at Pulumi. I started out on the engineering team, did a little stint as developer advocate, and now on the sales engineering team. My day-to-day is just helping users be successful with Pulumi. In my previous role, I ran a bunch of large Kubernetes stuff, and I think we installed 1.0. So I've been in and around the Kubernetes community for a long time and seen all of the good and all the bad. But yeah, I'm really excited to kind of show you what we've been doing here at Pulumi.
Awesome. And Vivek.
Hi, my name is Vivek. I have been with Pulumi for just a little over a year now. Oops. Sorry, obviously the call has to come in exactly when you need it. So I've been here just about a year, primarily work on the Kubernetes as operator and as well as the provider, basically part of the native provider squad. In Pulumi, I work on a variety of our cloud providers, so the AWS native as well as Azure and Google Cloud native providers.
Awesome. Well, welcome. Well, so for those who are relatively new here, so what I like to do as we're getting started is just say hello to all the folks joining us from all over the world. We have this is probably the worst time for us to hold a live stream if we want to get engagement around the world. So word to the wise, if any of you all want to do this stuff, because like West Coast US is sort of the tail end. This is getting into Friday evening for so many other folks. But we're also, lucky to have a lot of folks joining us. So let me just say hi real quick to Rodolfo, Martin from the Netherlands, Steve. Good to see you, Steve. Steve is out on the East Coast, works on Contour. Juka from Finland. Lamati is always here. Good to see you again, Lamati. Chaco, Eric, good to see you from Dallas. Khalid, David from Sweden. Janjun, An, good to see you on too. Fruit Company Country. Federico from Gothenburg. Federico hit me up in KubeCon once and gave me instructions on how to try and pronounce Gothenburg. But I think I'm still probably screwing it up. So I apologize, Federico. Yusuf Borko from Yusuf is from Morocco. Patrick from Sweden. Mikhail from Phoenix. Dean from Chicago. Prasad from Chicago. Oh man, it's always great to see everybody show up from all over the place. So the couple of things while we're getting started here. One of the things is that we have one of our community managers here at VMware, Tansu, Lori Apple, has been huge in terms of helping to arrange and get us organized around TGIK. I mean, TGIK has always kind of been my side thing, and I always haven't had enough time to really do it justice. And so she's done some really good work to help us get more organized and to really start setting up a schedule and start getting a little bit of preview of the stuff that we're going to be planning a couple of weeks in ahead. Because usually we're like, Wednesday rolls around and we're like, what's the topic going to be this week? And so we're trying to get a little bit better about that. And one of the other things we're looking at doing is having an alternate time that's more friendly for folks joining from either Europe or Asia, just because this is not a great time zone for a lot of folks. So stay tuned for more there. We're going to be publishing more of a schedule there. All right. So Joe, Lee, and Vivek, one of the things that we also do here is first off, we have shared notes. So if you want to actually, we have a HackMD, which I love HackMD as a service. You can get to it at tgik.io/notes. The URL is up here in the upper corner here. And we just like to crowdsource notes. So if there's links that you want to drop in, if there's things that we're forgetting, if you want to note something down, feel free. That's a great place to do it. And Joe, Vivek, and Lee, if you all have links or things that you think you want to talk about as we sort of go through this crawl, feel free to drop those things in there too. And so let me just go. I did a quick run. I don't want to get too bogged down in this, but I think one of the big pieces of news is that Knative has hit 1.0, which is really exciting. This has been a long time coming, and there's definitely been, a lot of ups and downs with the Knative project. I think the idea, from the get-go with Kubernetes, or at least maybe not from the get-go, but pretty soon afterwards with Kubernetes, is that we recognized that we weren't going to be able to do everything within Kubernetes itself. And so building frameworks, building toolkits that run on top of Kubernetes was really a big part of what we saw the things evolving. And Knative, I think, is a great example of building a whole bunch of stuff on top of it. Oh, and Carlos actually said he helped write this blog here. So thanks for that, Carlos. It's good to see that. So this really goes through a whole bunch of sort of everything that's happened in Knative and the road to 1.0. It's really good to see. One of the fascinating things in this world, and I'd love to get people, who are watching thought on this, is this idea of 1.0 and beta. And I think, there is this tension that we have in our industry where something can be production quality. And so we may call it 1.0 from a quality point of view, but we may be still learning and adjusting. And so we don't want to necessarily market, so that there's this idea of quality versus promises around sort of supportability over time. And so I think, especially when you have stuff that has a lot of APIs, you still want to be able to actually have some flexibility to learn and adapt without necessarily having to support everything for always. And we lost Vivek somehow. And so that's why in the Kubernetes world, you'll see us call certain APIs as beta, but the system and the implementation as a whole can be GA, and can actually be great. So there's always a lot of tension there in terms of actually how do we really express our thinking around promises and qualities to customers. So it's Joe or Lee, do you guys have thoughts on this? Is this something that you've struggled with, or folks in the comments if you have ideas around this also?
I mean, from my perspective, semantic versioning is a pattern that you can follow. Having a beta tag really just relies on your level of comfort. I've used so many beta software in production. I wouldn't like to tell people about it, but I mean, Knative has been around for such a long time, extremely well battle tested, incredible community, really talented developers. And I know that there are some very large projects built on top of Knative that are not only production ready but servicing customers on a day-to-day basis. So 1.0 makes sense to me, I think.
Yeah. Definitely agree. And Carlos in the comments is saying we need to get better at versioning CRDs and how do we actually manage. And again, a version is a promise. Calling something beta or alpha is a promise to users. And, just being as explicit as possible about how we actually make those promises, what they really mean. So, yeah, that's So I'm going to keep moving unless other folks have comments on this. Another thing that I thought was really interesting, and I my understanding is folks have been working on this for a while, is Google announced as part of GKE, this is an open source, their image streaming stuff. And this is really, really fascinating because what it finds is that, so much of cloud, so much of our world is around virtualizations, presenting this facade of something. And this is really presenting the facade that you have the image downloaded when you're running stuff. And so the idea is that you can, launch a container and then start accessing it right away, and then essentially stream in the bits that you need to be able to make this stuff work. There's a couple of, there's history here, at least in my time at Google, in terms of the way that App Engine worked back in the day is that, like, say, the Python runtime, whenever the Python runtime needed a file, there was actually a backend that would then go off and read that thing from Bigtable. And so it was never actually a file system sitting on desk. Everything actually ended up being going through some other sort of storage layer. And so this looks like taking some of those ideas and applying that at the container level, which I think is really interesting. It also really reminds me, it happens at the block level, not at the file level, of some of the work that is happening with Erecto in terms of managing duplication of file systems across different machines in a sort of, just-in-time tracking dirty type of way. So some really interesting stuff here. I haven't had a chance to play with it yet. Has anybody had a chance to start using it and see what they think about it? I would love to hear if anybody has any impressions from looking at it. So Carlos is saying network file systems have been for a while. I wonder why this is available now. What about open source like Containerd? I think, some of the concerns here, I think, are that, you look at something like NFS where things are just going over the network, and the failure modes there aren't great, right? Because, like, if the network hiccups or what have you, a lot of stuff can start falling apart. And so my understanding is, at least reading some of the Twitter threads on this, is that this is essentially the base image layer. So everything is read only. And so you can take advantage of very aggressive caching to be able to actually make this work. And so it's a fundamentally different thing than something like NFS, where it's just doing a full file system over the network. And so being able to do sort of just-in-time read-only population of a file system is, I think, what's going on here. But yeah, I think, things like IPFS is really interesting. And I saw that Nerd Control had support for IPFS that was just new. And so, there's StarGZ, which is essentially being able to snapshot and clone containers. So there's all sorts of interesting stuff going on in this world too. Have any of the folks on the call here had a chance to play with it yet? Have you guys?
I haven't had a chance to play with it. I did see it hit our native provider, or I think I saw it hit our native provider a few days ago. My first thought was, like, there's so much usage of object storage for these kind of problems, and latency becomes such a huge problem. I can definitely see the market. I personally have never run anything that needs images that fast, and I don't really want to be in that on-call rotation either. So I'm hoping that this will make a lot of people's lives a lot easier.
Yeah. Well, I think it's the combination of big images and needing them fast, right? And I think a lot of the folks who are doing this stuff from scratch, I think we know to keep our images reasonably sized. But there are definitely edge cases. Carlos talks about AI models down there. But when you're doing maybe a legacy Java application, it's not unusual to start seeing images get very, very, very large. So having this stuff be able to stream in on the fly seems really cool.
Yeah, in a former life, I spent a bunch of time with AI researchers, and those images are pretty massive. So yeah, this can be a fuse, definitely.
Yeah, and I think somebody dropped into our notes some tweets looking at IPFS support for Containerd and Nerd Control also, which is really intriguing. For those who aren't aware, IPFS stands for what interplanetary files. No, it's what does it even stand for? But, like, essentially it's a fully distributed peer-to-peer file system. It was Carlos that put that stuff in there. Thank you for that, Carlos. So I mean, it's a fully distributed file system with the idea that everything is based on hashes, and so names end up being stable. And so the example, I think, that the Nerd Control stuff is you can pull sort of IPFS here. There's a parallel thing called IPNS, which is essentially a mapping from like say example.com to this object. So there's essentially a metadata layer built on top of it. And then all of a sudden, of course, you start bringing in some blockchain and stuff like that for managing that mapping. But it's a really interesting, fully distributed type of thing. And I think that there's also, oh man, I'm blanking on the project right now. There is essentially a BitTorrent like system for distributing images also, which I believe now is part of the Harbor project, which is, I think, really interesting. So yeah. And David's saying huge Windows images, which is true. I don't think the GKE service supports Windows images yet. At least that was, the supposition that I was reading about there. So yeah, so very cool. And then I haven't like looked at it, but I saw this really interesting blog post. Maybe I was Hacker News or on Reddit. That's going through sort of the different logging architectures for doing logs, essentially breaking down, grabbing stuff using a daemon set and essentially standard error, standard out, or essentially using a sidecar to be able to log to a file and have the sidecar be able to actually pull that stuff out. And I just like the diagrams and like the idea of like, hey, there's like multiple ways to skin this cat. So this looked like a really, really interesting blog post that you all can check out if it looks interesting. All right, let me read through the comments here. Who runs Windows on K8s? It turns out that a lot of folks are really interested in running Windows in Kubernetes. It's actually one of the huge features that we see folks using out of one of the TKG offerings that we have, TKGI. Let's see. Choco's saying that Uber has something called Kraken for distributing P2P images. I haven't seen that yet. Dragonfly is the name of the Harbor adjacent project for doing this stuff. And then Eric's saying that NVIDIA has some huge images for ML stuff. Yeah. ML stuff starts getting really, really big. And, and I think this is one of those things where, have you all seen this? And this is something I want to talk about with respect to Pulumi also is, have you seen this sort of OCI registry as storage project? This is this idea around, we use OCI registries for distributing images, but we can use them for distributing other types of data also. And so one of the things I'd really like to look at, and I think, if I had more time, was maybe a CSI provider for Kubernetes that could actually load or as, type of images into a volume so that you can distribute large binaries using the OCI registries and then be able to actually use that as essentially a volume. I think that'd be really interesting. Or for distributing things like machine learning models, because all the concerns around supply chain and signing and tracking that go into your images, you're going to want all that same stuff for your machine learning models also. So yeah, it's a really interesting area to see these things converging in terms of storage. All right, I want to keep going. And then, oh yeah, the container apps. I meant to do this. Somebody put this in there also. So Dapper joined as the CNCF. It was a sandbox project. Now it's an incubation project. And then there's also these Azure container apps, which is and I'm probably doing it a disservice. It's built on Kubernetes, but it's kind of like Cloud Run for Azure is my TLDR there. If I have that wrong, let me know. But that looks really interesting.
Yeah, I think it's built on Keda underneath, so it's scaled to 0. Really good, really good for hobby projects as well. They have a really generous free tier.
Oh, that's awesome.
Yeah, I deployed a couple stuff with that with our native provider earlier in the week, and it was a really, really great experience. So.
Yeah, that's super cool. And I love that we're seeing this spectrum of options here. And I think the interesting thing is that we have everything from sort of like, here's some code, just run it, I don't have to worry about, down to sort of like, I want to manage my own Kubernetes. And I think as many concepts as we can share to sort of ease transitions between these worlds, I think the better off it's going to be for users.
Yeah, the thing I also love about it is just with the whole Dapper project is kind of moving the layer of abstraction up a little bit, where we can start thinking about these things as real distributed systems and not just focusing on the containers and the pods, but how they all relate to each other. And so that's cool to see.
Yeah, I mean, with Dapper specifically, I'm really interested to see, I look at Dapper, I look at Spring, and I look at Istio. And what you see is that there's the same concerns that are being addressed at slightly different layers across these things. At Istio, it's being done at sort of the network packet level, sort of like the L2, L3, L4 layers. With something like Dapper, your application has an explicit API to talk to a sidecar, and there's all sorts of services built into. It's a mesh, but not a network mesh. It's a sort of a mesh for getting other information and other actions, but it's an explicit thing, right? And then you have something like Spring where this stuff gets built in at the language level as a bunch of frameworks. And there's I think we're still figuring out, the right place to put different functionality, and then how do we create interoperability around this stuff too? Oh, Microsoft wants to know what I think here. Not right now, Microsoft. Sorry. So yeah, so I think that drifting of capabilities between these systems, I think, is really cool. All right, so that is the news from Lake Wobegon. Oh wait, I can't say the name. That's the news from around the Kubernetes world. Let's go ahead and start talking about Pulumi and the Kubernetes operator. What we have here is I have a bunch of stuff, and so my idea is I want to jump in and actually get stuff going. There's sort of the tutorial that is out there for everybody, and I know that since I sort of let Joe know, hey, let's do an episode on this, there's been some work to sort of like polish these up a little bit, and I appreciate you all helping out with that. And then I think Lee, you dropped this in that there's you created a demo that is do you think we should work through this one, Lee?
I think so, yeah. It is hot off the press, as you'll see, committed 28 minutes ago. So,
we'll learn as we go.
I've run it a few times. It worked for me, but, we're live now, and so we'll see how it goes. But this should show you an idea of the kind of thing and the kind of value proposition that you would get from the operator. I think it's really important to kind of start off with saying why you might choose to use the operator. Obviously, if you are following along at home and you've never heard of Pulumi,
I did want to back up a little bit and get from like one of y'all, what the heck is Pulumi and where does it intersect in this world, right? So I can try and give my explanation, but I'd rather hear it from the proverbial horse's mouth.
I mean, we got three experts here. Who do you want? Joe, would you, considering it's your company, I think I'll let you take that one.
Sure. So Pulumi is an infrastructure as code platform that lets you use general purpose programming languages to do everything we know and love about infrastructure as code. But because it's general purpose languages, you get abstraction, you get sharing and reuse, you get, for loops and functions and all those great things. So we support lots of different languages, Python, JavaScript. But we support lots of clouds too. So AWS, Azure, and Kubernetes has been part of Pulumi essentially from day one. So if you want to express Kubernetes configuration, you can do that in Pulumi and connect it to other pieces. Like maybe you want an RDS database instead of managing your own MySQL instance in your Kubernetes cluster. Maybe you want to provision Kubernetes clusters themselves, connect them to things like CloudWatch, Route 53, the Azure equivalents of those. But what we find is, okay, it's infrastructure as code. You can run the CLI. That's great. It's great for tight loop, sitting in your editor. Because it's a programming language, you get refactoring, all the great things about editors. But when you go to production, most people are going to want to automate that. So how do you automate that? Well, we have a few different options. We integrate with CI/CD systems. So maybe you want to use Spinnaker, maybe you want to use GitHub Actions. But actually, we're increasingly finding that folks want to manage these with operators and actually trigger those things off of maybe Git commits and so really doing the deployments from within the Kubernetes as a controller effectively with, we have policies code for admission control and things like that. So increasingly we're finding folks that are really living on the bleeding edge of cloud native everything really are picking the operator to do their deployments. And so that's kind of how we got to where we are. Lee, did I do okay or?
Yeah, I think the one thing that I will say is that, the traditional mechanism for deploying infrastructure is, somebody has a command line tool and they either shove it into a CI/CD pipeline or they run it locally on their laptop. There's other infrastructure code tools out there in which that's the kind of desired workflow. The building block for the Pulumi Kubernetes operator is the automation API, which is kind of unique to our product in the sense that, and it's all open source. Everything we're talking about today is open source. So the automation API allows you to build your own custom workflows when you're actually provisioning infrastructure. So you can do things like build Heroku-like command line tools that will allow you to actually deploy things in kind of suiting your workflow. The Kubernetes operator is just another one of those workflows. If you're really used to Kubernetes operators, you're used to the reconcile loop, we've already done the work for you. And part of the reason why this came along is once the automation API came out, everyone was like, well, this looks perfect for a Kubernetes operator. And Joe went away for a weekend and was like, here we go, let's start something off. And Vivek has taken it from there, and it's now, it reached 1.0 recently and is now production ready. And so these two things molded together. The operator is going to show you, if you're used to the Kubernetes reconcile loop, then that's one way of doing things. But one of our colleagues built a web API that will allow you to do deployments as well. So there's so many different things, and the sky is really the limit because of this automation API that allows you to define these kind of infrastructure as code workflows. So if you're someone who has ever kind of waited 20 minutes for a CI pipeline to wait and been like, why am I waiting so long and why am I refreshing this page? The automation API is probably going to be something that you're going to enjoy. And the Kubernetes operator is just building on top of that.
So one of the things that I've heard from customers explicitly is, they like using Kubernetes because it's very easy to integrate Kubernetes with other systems. The declarative nature of the Kubernetes APIs of like, hey, it's just plain data. I can just push my data to the cluster and relatively reasonable things happen. Sort of the basis of, the whole GitOps idea is that, and I think that combined with operators really means that we can, maybe we lost Joe. He might've closed his window. That combined with operators means that it's really easy for us to integrate with something and really bring it, to integrate with higher level systems and have them drive a set of workflow automation things. Now, one of the interesting things, and we probably won't have time to explore today, but we recently introduced this project as part of Tanzu called Cartographer, which is essentially a supply chain orchestrator. And this is the idea around, like, how do you actually take a bunch of steps in your supply chain and stitch those things together? Right now, what happens is it's a bunch of fragile configuration between a bunch of different systems where it's like, oh, at the end of my Jenkins pipeline, I want to run this command that then runs this other thing, right? And so configuring and hooking those things up ends up being really complicated. The idea with Cartographer is that it runs each of the steps and then takes care of marshaling from one step to the other using Kubernetes as the model. And so I think it might be really interesting to look at a combination of something like Cartographer and the operator that we're going to be looking at.
Yeah, actually, one nice thing that actually dovetails nicely into this from a supply chain, security standpoint, because we sometimes call it infrastructure as software for Pulumi, which
is because what infrastructure as code never really made sense to me, to be honest, because it's like a lot of times it's just config, not actual code, right?
Right. Well, maybe the C actually does stand for config, and we're all just confused.
Yeah.
It stands for code. But the cool thing about it is you can take everything we know about software and apply it to how you're managing infrastructure, including things like versioning. How do you patch, problems? How do you release new versions of your infrastructure? And kind of one of the neat things that Pulumi can do is actually do the upgrades. So from point A to point B, you really can use semantic versioning for your infrastructure if you want to, which brings all this like software supply chain concepts to the world of infrastructure as well. So I agree. I think these would be better together.
Yeah, and I think that's a critical thing that I think people are starting to get more and more cognizant of now, is that you can be great about controlling your binaries, but like the way your binary behaves can change dramatically based on an environment variable or a command line flag or the dependencies that you hook it up to. And so you need to be able to control that stuff just as well as you control any other code that goes into your app.
Yep.
All right. So let's go ahead and get started here. I think, let's see, let me close some tabs. So we're going to start with, so here's what we have going on here is I played with Pulumi a little bit, this morning and yesterday, just to make sure I wasn't too far off. We need to create an S3 bucket to store state here. So now when you're launching Pulumi, you have a choice. You can use the Pulumi web service, or sort of SaaS service, which there's a lot you can do with that for free. and you get an API key, and that'll store essentially your state file, essentially a mapping of the Pulumi sort of program concepts into the cloud concepts. There has to be sort of a mapping and tracking there, and can store configuration variables and secrets. You can also store that stuff in something like an S3 bucket and then encrypt the secrets using KMS. So we're going to play around with actually doing that stuff out the gate, just to try and keep it pure open source. But you will get a good experience, a better experience if you're using the Pulumi stuff. At least there's a video at the bottom of this page here where you can see, who was it, Mike, that actually went through and did this video. You can go through and like click from the Pulumi, see what the state is and decode it. But we're going to do something a little bit more raw with the S3 stuff here. So I'm going to create a bucket here. I'm going to call this one TGIK Pulumi State, something like that. I'm going to be operating US East 1 like everybody else in the world.
And let's just hope that it actually stays up for the, for the entirety of the demo. You can never be too sure. I'm sure Corey Quinn's twitching somewhere. The US East 1 usage.
Okay, what did I create bucket? Okay, yeah. Oh, copy settings from bucket. Okay, there we go. Yeah, no kidding, right? But I'm pretty sure that like if US East 1 went down completely, I wouldn't be surprised.
StreamYard would probably go offline. I would imagine so. Yeah.
So now we have a bucket here, and then there's nothing in the bucket, but at least we can talk about it. And that thing is TGIK Pulumi State. Now, some of the other stuff that we have going on here is we have a couple of things. We can create a Kubernetes secret using our AWS credentials. The other thing that I have, and let me pull that up, and I'll just put a link in here. If we go to github.com jbeta, and I think I have dot files. I have this little bash script here that I just wrote this morning, which essentially essentially uses the AWS config to like preload this stuff into your environment. So this is a really useful little thing here too. And I'll drop that into the init environment from AWS CLI config. But yeah,
it's worth kind of mentioning as well, like if you're running this inside a cluster inside the cloud environment already, there's usually some OIDC mechanism to talk to the cloud provider. EKS has IAM rules for service accounts. I forget what Azure's one is called, and then GKE has one. Obviously, because I think you're going to run this on a kind cluster, right?
Yeah. Yeah.
And so you need to provide credentials so that Pulumi knows how to talk to the API somehow. And so this is just obviously the most straightforward way.
So here we're going through. So we're creating a secret, and then we're initializing that secret based on the stuff in my environment. Oh, what did we do? What did I do wrong?
Do you have an old kubectl?
Kubectl create secret. Oh, you know what? You need to specify generic.
We've got a question. It's my favorite question. So while you're figuring this out, I'm going to jump in. So Borko just asked, state file, is this the same Terraform state file? The state file is considerably different from Terraform. It's got the same mechanism of creating a resource and then storing the state of that operation in the state file. And then another common question is Pulumi using Terraform providers under the hood? There's two ways to look at this. The first is that we use some Terraform providers to actually map the create, replace, update, delete parts of the schema, but we don't execute the Terraform providers. And the second thing is we talked about native providers a couple times already. The Kubernetes provider is generated programmatically from the Kubernetes API. So when a new version of Kubernetes is released, so 1.22 came out a few weeks ago, we get the next day support for that because we programmatically generate those resources directly from that API. It's a very common thing that comes up, like you're just using Terraform under the hood. It's not actually true. So I'm here on record saying we don't use the Terraform providers. We just use the schema and the replace and update and delete mechanisms. Joe, I think you were originally part of the person who put this together. If I got any of that wrong, then please let me know.
Yeah, it's generally true. We wanted, folks to be able to use any of the Terraform ecosystem, and so we support, any provider that Terraform has. We can plug into Pulumi and use it. But our native providers in general are, support the entire cloud. So Azure is Open API based. The Kubernetes one is Open API based. The Google one is actually Discovery Doc based, which I don't want to trigger you, Joe. I know you have past history with Deployment Manager, but our native providers are really great. And Carlos asked, why do we need state in the first place? It's really to map I think Joe kind of spoke to it earlier in a nice way, which is mapping the Pulumi concepts in your program to the actual underlying cloud resources. And we have to be able to do diffs. And it's also good to know, like, what is the last known deployment state? So you can actually do drift detection to detect, hey, is the current live state in the cloud different from what we thought we deployed? So there you have.
What's interesting, though, is that I think, some of the ways that we define the Kubernetes API and the degrees of flexibility you have with Kubernetes allow you to annotate things to the point where, if you're building deployments against Kubernetes, you might be able to get away with not having something like a state file and actually have annotations and labels on top of the objects. Not every cloud lets you do that. And even in something like AWS, the support for tagging and annotating API objects is very mixed across all the different types of objects. Yep. And so, just this need for a state file is just a reality when dealing with backends or services that you're targeting that aren't super flexible in terms of carrying along sidecar annotation data.
I think if we talk a little bit more about the state file as well, like Carlos is making a very good point that, like, with the GitOps mechanism, you're matching the Kubernetes etcd state, or if you're using a Git repository, you still are driving towards a desired state. That state is just stored in a different place. So with a Kubernetes operator, the state is in etcd and you're reconciling on the etcd state. And with GitOps, you're reconciling on a Git repository's last known commit. The only difference with Pulumi is that we use object storage and a HTTP interface to actually do that. So the model is essentially the same. You just don't have this file that that you're actually dealing with. And in some ways, it can actually be better, in my opinion, because if you're Kubernetes, if you're etcd, if you're unlucky enough to be using a non-managed Kubernetes cluster and you have to start manipulating etcd manually, it's a pretty difficult operation. Whereas with the state files, you can just manipulate the file themselves.
There's also the possibility, for example, like as Joe perhaps mentioned, that you could store state alongside the object, essentially, like Kubernetes has tags or annotations and whatnot. But there's also the situation where you could lose resources arbitrarily, where that particular item no longer exists. Like that reconciliation is something that with the separate state that we store, you could achieve. Obviously, there's ways around it, but that's one. And for Kubernetes in particular, we do essentially. Because we know there is this, latest state available for Kubernetes, we do a degree of three-way diffs as well. But that's not the case for a lot of other resources. And Pulumi, as you know, works with a large variety of providers.
All right, so I'm jumping ahead here a little bit while you all were answering that. I went through and deploy the operator, links to the instructions here, and you can deploy it either using Pulumi itself, but I don't want to get too inception-y here and actually confuse people. And so I'm gonna deploy it with kube control directly. That takes us here, and I downloaded the latest release, the tarball, and untarred it. And so we're at this point here. I don't know if you all saw me do that. So what we have is we have the CRDs. And so let's go through, and if I pull up VS Code, we should be able to see deploy CRDs. So we have, it looks like, is there just one CRD that we're deploying, which is the stack CRD?
That's right.
That's correct.
Okay. Okay. So this is essentially stacks.pulumi.com is the name of the CRD. It's a stack. And okay, so we'll get into that. So let's go ahead and deploy that. Kube control to apply -f. That's so now you go get stacks. It's going to probably tell me you don't have any stacks yet. Of course not, because we just created the CRD. So that's working. And then we can go ahead and run the operator itself. So let's dig into what we have there. So this is going to be, okay, so the operator runs. So now the question is like, okay, so what we have the operator itself. So we have a deployment for that. A role and a role binding. So the role is essentially it runs, it's getting a lot of resources, because by the time you get to secrets, you pretty much own things, but it's a role, not a cluster role. Which is interesting. And so what that tells me here is that the Pulumi operator is built right now to run on a per namespace basis. So it's not a case where you install this into a cluster and it becomes a cluster-wide service. It really is sort of like running in your namespace for your thing. There's an interesting, and this is, I think, one of the problems with CRDs and stuff like this, where it's like the CRD definition is cluster-wide, but the Pulumi operator itself is actually per namespace. And so, from a security point of view, that's great, because like, hey, you're not going to be necessarily looking outside your namespace to be able to do things. And so you have that cordon from a versioning point of view. And I think this gets into some of these things. It gets a little bit tricky, because what you may find is that you're running different namespaces are running different versions of the Pulumi operator, and they may assume certain things about the CRDs that are running under the covers. And so that's something that I think is going to, is not something that we necessarily have great answers for across the Kubernetes ecosystem in terms of how to deal with some of those version skews. All right, I want to catch up on some of the, oh, go ahead, sorry.
I was just going to say, like, my personal approach with anything like this, that is allowing you to create resources and is allowing you to create, cloud resources, it should be in a privileged role. Generally, I would advocate for a dedicated cluster that is allowing you to actually run kind of privileged resources, not running it in the same cluster with your, application stuff, simply because, like you said, if somebody gets control of your Git repository, or somebody's able to get control of this role, you're kind of in a bad shape already, and you can pivot pretty quickly. So yeah, I generally recommend for any customer that comes along just to kind of keep this as separate as possible.
Yeah, and in some ways, like the role that we are providing right now does allow you to create additional resources within the same cluster, but that can be pared down. This is mostly from a usability perspective, like being able to do something locally for your cluster. But certainly, as Lee pointed out very correctly, that is actually how a lot of our hardened users are actually currently using the system, is to pare down that role significantly.
Yeah, and I think, this is definitely something we're seeing through the lens of Tanzu, is that we're definitely seeing a tilt, at least right now, towards many small clusters that are more single purpose versus a few large clusters. And, coming from the Google point of view, and I assume the Red Hat point of view in terms of previous versions of OpenShift, that's a kind of a bit of a surprise, right? Because Google Borg cells are big and are very much multi-tenant and shared and multi-purpose. Whereas I think, with, early on services like GKE, creating, being able to press a button and create a cluster means that it's very easy for people to create a lot of clusters, and it tends towards more of these single purpose type of clusters. And I think what that means is that in the Kubernetes ecosystem, a lot of the cutting edge stuff now is how do you actually start creating communications and stuff across different clusters. And so some of the stuff that we're looking at from the Tanzu point of view is like, let's say I'm running an operator in one cluster that's launching and managing a Postgres instance. How do I then automatically, access that from a different cluster? So creating automation around cross-cluster service provisioning and access ends up being a really interesting area. And that's one of the things that I want to look at the Pulumi operator through the lens of.
It's interesting. We actually have folks who create Kubernetes clusters from within their operator running in Kubernetes clusters, because you have the full access to EKS, AKS, and all GKE from within the Pulumi model. You can actually do that from inside the operator. We actually have this, because we're talking about stacks. Stack is sort of the CRD, but a stack is a pretty primitive concept in Pulumi, which is, you think of it as an environment in a sense. You might have one project deployed to 10 different stacks, right? And it might be production, it could be staging, development, it might be production East Coast, production West Coast. One of the cool things we have is a stack can actually depend on another stack. So oftentimes your Kubernetes cluster is going to be in one stack. Maybe it's consuming a VPC in Amazon because it's deploying into that from a different stack that defines the subnets and everything. And then maybe you have application services that are consuming the kube config that we're using to deploy into from that Kubernetes cluster stack. And so to your point, you might provision an RDS database or Postgres in one stack, but then consume it from others. When you have these references, Pulumi understands the dependencies. And so in principle, you can track down, who's depending on what. And if you perturb something at a lower layer, you can know that, hey, you're going to have downstream impacts as a result of that.
At least be able to map those dependencies.
Yes.
Yeah. All right, let's keep going. Okay, so we have the service account role and role binding. We have all that stuff going. The deployment here is pretty dead simple. Nothing super fancy. It's just a single operator that's running, and it uses that service account to be able to do things. One of the interesting things here is that, because this is a sort of a per namespace thing that you're operating within, I think by default, at least, one of the things we were talking about before we went live is that if you're executing a Pulumi stack that talks to Kubernetes itself, by default, it will use that service account both for the operator, but also for executing a stack. And so that becomes available through that also. One of the things that might be interesting here would be having a different service account for execution from the operator itself, so that maybe you can constrain or expand the execution context by default. But let's go ahead and at least get this stuff up and running and make sure that we can get it going here.
Yeah, one of the things that we have been talking about, and we hope to do very soon, is being able to do exactly the kind of thing that you were talking about, and also sort of have the stack runs happen in a self-dedicated sort of job, essentially, and like that can be a heavily pared down sort of environment, and that gives you that degree of like hermetic kind of environment as well. That's something a lot of people have requested, and definitely would be interested in doing that.
Pataka's asking, is the operator using global credentials to talk to the cloud provider? No, I think what happens is that if it's Kubernetes and you're talking to the local cluster, it'll actually use that's what we were talking about, the credentials that were provided to that service account that we just created here would be used there by default. But you can also, when you define the stack, and you'll see this, one of the things that you put into the stack is the credentials that you're using, or you can pull those from a secret. And so that's why we created that secret with our AWS credentials earlier on. So we'll definitely get to that. Okay, so now I think, let's see, is this thing? It's still container creating. Is it downloading?
We need those like streaming images that
I know,
I was just
right?
going to say that would come in real useful right now.
I have a very fast internet connection, so yeah, we're up and running. I'm lucky enough here in Seattle to have gigabit Ethernet, so I'm getting spoiled by it.
I come over to your house because, like,
yeah, for sure.
I have 30 megabits right now out here on Whidbey Island. It's so painful. I'm jealous, Joe.
Yeah, Joe took the opportunity during COVID to move out to the islands, and so no longer here locally. Okay, so the example that we're gonna, we weren't gonna work through this example. We were gonna work through this example here. Okay, so this is, if you look at our notes here, just to keep everybody on the same page, that's the TGIK operator demo. This is the link that we're working through right now here, and this was Lee was nice enough to pull this together for us. Okay, so now we install. Only installs the operator itself. We now need something for the operator to reconcile. And so the way that this works is that we're going to create a CRD, and this CRD is actually going to talk to a Git repo to be able to actually download the Pulumi code that we're going to actually run. So this is the Pulumi program. Now, normally, correct me if I'm wrong, guys. Normally, when you run Pulumi and you have something, you run Pulumi up, the execution of the Pulumi program happens locally on your machine when you run Pulumi up. Is that the
it
case?
happens in the context of wherever your command line interface is.
Okay, so that could be your Jenkins instance also, is not
CI,
uncommon.
GitHub Actions, whatever your CI/CD is.
Yeah, it's a really good point because, like Terraform Enterprise, if you're familiar with that model, it's actually server-side execution. But because it's client-side, it means your credentials can live wherever they typically live, distribute them on the client. If you have a CI/CD pipeline that's like super locked down, you run our CLI from there. The security model is actually a lot of folks we work with prefer that model. So it's an important point.
Because when you deploy something, you're deploying it using your credentials as you. So there's a certain sort of personal attestation around that. Yeah, I mean, it's interesting. Some people like that. Some people like to be able to say, have this running on a machine where everybody has visibility and there's a lot of auditing. I can definitely see pros and cons around that for sure.
Yeah, most of our customers, when they move to production, they'll lock down their delivery pipeline. Okay. So maybe it's in GitHub Actions or Spinnaker or the Kubernetes operator and use short-lived credentials. But then development is typically on the client and developer desktop. So
yeah. When I talk to folks, inside of Tanzu about this, I often talk about sort of like the spectrum between YOLO ops and responsible ops. Right. And so when you start off developing something, you just want to get it out there and not sweat the details about it. But over time, you have to get to the point where you have all the good supply chain stuff and auditing, and you're responsible about things, and you do security scanning and all that. And so I think the challenge in our industry is how do you progress from sort of YOLO ops to responsible apps without having to rewrite the world and without having to reset things, being able to actually make that be a reasonable transition.
Yeah, one cool thing, by the way, I know we're using the S3 backend, but if you use the Pulumi SaaS, it's got auditing built in. And I think of it as almost like what GitHub is for your code changes, Pulumi is for your infrastructure changes. So it tracks all of the fine-grained details of exactly who changed what and when. And It has a bunch of integrations with different identity providers. So if you want to use GitHub for our auth or Atlassian or...
But the actual program that you run to actually generate the resources, it's very difficult for Pulumi to capture the sort of the sum total of everything that goes into that program, right? Because you're not always running containerized. You might have a weird node configuration on your computer because everybody has a weird node configuration on their computer, right? So it's like the sort of it's not as hermetic as all that, but the results end up being auditable, right? Because it's this person ran a program. We don't know exactly what they ran, but it caused this EC2 instance to be affected in this way. That's the stuff that you all can catch then.
That's right. It's hard to wrap your head around how Pulumi works initially. It's somewhere on the spectrum of imperative to declarative. Sometimes I call it implerative. It's like this new thing. It's terrible. But Pulumi actually produces a plan in an object graph that represents the desired state of your infrastructure. And that's actually what it operates on. All the language is different languages you can write in are actually just kind of syntactic sugar for building that resource graph. And so Pulumi captures the graph, and that's what the diff is based on. That's what the deployment is based on. And that is fully captured and auditable and diffable.
All right. So the way that this works is that when we run this stack, the back end, this is actually where it's going to be storing and running. Okay. So a couple of questions here. When we launch so the back end, is that specified? That's not specified on the operator. The backend that you're using is actually on a per stack point of view. Is
every stack has its own, can have its own backend. What I will say, by the way, Joe, is that this README, I missed a couple of fields, so I've updated the HackMD with some added fields in there. So you might want to use that one. I'll update it after the stream is over. So this one is here. So there's the backend is important. That's where the state is going to be stored. And then there's a KMS key as well in there, which will allow you to encrypt your state. Which is we're going to be using a secret value, so we do need to actually create it. I can't recall if we created a KMS key or not at this point.
I'll show you. I did one before, and so so let's go through and we'll do it this way. So we have this is called TGI demo. I named the file myfirststack.yaml. The back end here we're going to be using S3, and so my S3 bucket that we called was TGI Pulumi State, right?
Yep. I'm very surprised that that wasn't. You obviously haven't used Pulumi before, because S3 buckets are globally unique, right? So
this is the first time that I've created this bucket with this thing. So
yeah.
I created a new Amazon account for this just for TGIK, because my old Heptio one got chewed up at some point during the VMware transition. And then the key management service, I created this earlier also. Is essentially just a symmetric key using the default stuff. And I created an alias for it called Pulumi Secrets. And so I believe the way we do this is alias and then Pulumi Secrets. Is that...
You tried this with aliases, Vivek?
I kind of prefer to just throw the ARN, so like I know for a fact that, you know, I didn't screw something up, kind of thing.
Okay, so in that case, I want to grab... What do I grab? Do I grab the full... Oh, I had the link to the
I think you have to copy the ARN actually from the, if you look at the console.
Okay, so the secret encryption, here's the Pulumi docs that go into this, and it has sort of like the AWS one. You can do it by alias or ARN, or... Okay, so we'll do the ARN one. Okay.
I just prefer to do that just to avoid any fat fingering and whatnot. Like the less I type, the better.
I did just double check. You can use aliases, but you need to specify the region as a parameter.
Okay.
So you can use the alias, but you need to make sure you get the right region on there as well.
Okay, and so even with... Okay, this one has the region embedded in it because it has US East 1 in the...
Yeah, it's a unique ARN, whereas if you use an alias, you can use it... There you go.
Gotcha, like that. Okay, well, we'll just do the ARN, because there we go. And so this is what you're doing if you're doing it from the command line. But here, we're not initializing the stack from the command line. We're initializing the stack from the operator. So the operator is going to be essentially running the Pulumi command line for us, is what's happening. Okay. All right, so we have that going. So let's go through and see what we have here. So we have the backend is S3, the secrets provider. And then what we're doing is that we're providing some references to secrets that actually have our access key. And then we're actually saying, here's the region that we have going on there. And then the stack that we're calling it, so this is the name of the stack. So tell me about the names of stacks. Like, how do you guys name stacks? This is a little bit confusing to me, to be honest.
So with our SaaS, you have the concept of organizations and projects that live inside the SaaS. And so a stack name inside the SaaS is simply something as simple as dev. You can quite happily just call the stack dev within your S3 bucket, but because it's at a global level in the S3 bucket, you can end up with stack naming clashes. So you could just call this dev.
To figure out with the S3 bucket how you want to name a stack, and you can name it whatever you want.
Yes.
With the Pulumi service, there's some structure implied by this.
Yeah, so what we would usually call this is something like tgik.dev, and if you wanted a completely reproducible example of this, you would call it tgik.prod. And obviously with the Pulumi service, it has a little bit of like it's got the RBAC control in there, so that's a really good reason to use it.
Okay, so then the project is not really something that the Pulumi open source stuff understands. Project ends up really being something that's a concept on the SaaS side, and so that's really. Right, yes. At the end of the day, typically people would use the same program across all stacks in a project. It seems like, but like really, every stack stands on its own and has its own program associated with it and what have you. Okay.
What we'll see when we actually instantiate this is that you'll see that each stack has its own state file. So when we actually run the operator and you go look in the S3 bucket, it will have its own unique state file in there. And the reason that you have to give it a unique name is that you can't have two files in an S3 bucket with the same name. That's the main reason.
By the way, one useful thing about stacks, by the way, is config. I don't know if we're going to touch on config today, but each stack has its own configuration. So what's very common is you have one program that defines, a configuration of some set of infrastructure, but then you want to conditionalize it based on, hey, my production instance, maybe I have, 3 nodes, and my, dev, I have, 2 or, something like that. So config is a good way to parameterize these without having to copy and paste the same config all over the place.
Okay. I think I get that. So the stack is just a key right now for this. If you're using this with the Pulumi SaaS service, there's some other sort of semantics that come along with it. And with the stack is a state file, a set of parameters, and there's typically, if you're using the command line, you don't have a pointer to a Git repo because you're running the stuff locally. Here, you're actually running this stuff based on the stuff that we're seeing in the command line. Is there support for having sort of GitHub credentials for being able to grab this stuff from Git?
Yes. So if you look at the full like the CR documentation, I think I meant to put a link for the CR documentation. Let me go ahead and do that actually right now. You will see things like Git auth capabilities. You can put SSH keys and things of that nature. So
okay. So yeah. So there's a whole bunch of stuff that you can go ahead and do there.
And then somebody asked a question, can you track a specific folder inside a repo? That is another part of the stack CR as well. And it's all really done from Git references at the end of the day, right? And so you can track any, a common pattern is people will put their Pulumi code next to their application code. And you can have like an infra folder or a deploy folder or something like that. And the operator can point at those different folders as well.
So one of the things that I think, and we probably won't have time to explore it, is if you look at Flux v2, it's essentially a toolkit of a set of controllers, and one of these things is essentially, if I'm finding it right, is essentially knows how to reach out and track the latest Git SHA and stuff like that. So the idea here is that instead of actually having something always grab latest, you could have, so like I would love to. So one of the things that we're doing with like customizing some of the Tanzu stuff is actually having a duck type schema for CRs that represent essentially a Git reference. And so now what you can do is you can have something like Flux say, well, every time this branch updates, update this Git reference. Or you could have like, well, somebody has to sign in blood to update the Git reference. And so there ends up being essentially a way of, just like you're referencing a secret, to reference a Git reference and then be able to actually stitch that into other pipelines. So yeah, so that's really,
I think really something that's actually made me think of that we should add as a feature, Vivek, is only being allowed to apply signed commits would be a very interesting way of actually having the operator run, so that you can have that. Yeah, you can start to get to that place. I mean, you can lock down my branches and do pull request reviews and all that kind of stuff, but having only allowing signed commits would be an interesting, enhanced security model as well.
Yeah, actually, those are all great points. And I think a lot of this has come through in the community at different points. Like, in fact, one of the things that someone suggested was essentially globbing on to, the source control capabilities that Flux has. So, like, if you were to say, hey, like, make a reference to a source control, CR, essentially as your Git repository kind of thing, and basically have that interoperability. And so, for example, if Flux has like all these capabilities to deal with your signed commits or whatever it is, all of those things you kind of get for free. And to be honest, like, tracking source control is not like the thing that is most.
Yeah, that's not what you guys are spending your time doing.
Yeah, we actually originally were looking at using Flux for some of this, and at the time they just started breaking out some of the controllers and decomposing it. It started a bit more monolithic, but that's definitely leveraging that stuff. Awesome.
Yeah, I think another thing that we're looking at, and I think this would be interesting, is that instead of grabbing this from Git, being able to grab this from an OCI registry would be interesting also, right? Because with that ORAS stuff, that's really ends up getting interesting. And so, like, one of the things that we're looking at with like cloud native build packs, for instance, is that typically what you do with cloud native build packs is that you point it at a Git repo or you upload your source code to something like S3. But now when you're deploying, especially if you're doing on-premises type of stuff, you don't always have an object store. So actually having, storing source, again, the same way that you're going to manage models, the same way, like being able to actually reference source to be able to grab this stuff ends up looking really interesting also.
Absolutely.
All right, cool. And then destroy and finalize means that when I delete the CR, it's actually going to delete all the things that CR created, so I don't leave orphans around, right?
That's precisely it.
Okay, so I'm going to try and deploy this, and then we're going to see what happens. That sounds good?
The moment of truth. Let's see if I am actually a software developer by trade. We'll see how this looks.
Apply-f my first stack.yaml. All right, so we passed the schema validation here. Kube control get stack. So we can see it. TGIK demo does it.
should have a status field, right?
Yep. So it's starting out right now. Let's see. Go down. Can you do a describe? If you do a describe on it, you should actually see it show up as well. So.
Without the flag, I've made that mistake so many times, Joe. So many times.
Right.
All right. It looks like it's not reconciling yet.
Not yet. Interesting. It normally would detect the. Did we get the right path? AWS canvas.
So if I look at the operator here, let's look at the pod here. It's running. Logs.
Got some issues.
Failed to create or select stack. No credential providers. Okay, so what happened here?
So you have. Did you just make sure that the secret is correct?
Oh, you know what? We probably didn't match up the names on the secret. Okay.
Yeah,
so
if you want to just take a look at that, that'd be good.
Yeah, let's go ahead and do that. So AWS creds secret is what we called it. And I shut down Octane. Cube control get secrets.
Is it in the? Shouldn't the AWS cred secret be in the same namespace as the operator?
Yes, it should be.
And it is.
It is in the same namespace as the operator. I'm doing this all in the default namespace. So
got it. And so
okay,
and then
AWS access key ID. Cube control get secret. I may flash my secrets on the screen here, in which case that's not the end of the world.
It's
somehow
empty.
It's empty. So something happened there. What did we do wrong? Okay.
Did you run your environment?
I did. Maybe wait, what is Octane's still throwing weird errors. Okay. So let me AWS. I have my load env. This should do it. Here, I'm going to turn off my screen here for a second here while I do this. Let's see. Let's see. Env.
It's more authentic when it's like this. If it goes right the first time, it looks way too professional.
My stupid bash script thing didn't work. I'm going to have to fix that. Darn it. It was seriously working like 5 minutes ago. Okay, so give me a second here. Let me.
I guess while you're doing that, we could go and address some questions.
Yeah. Go ahead, and people can watch me faff around with this stuff here.
By the way, I'm very, very happy to hear you use the word faff, Joe. It's a word that I've been trying to get across from England for a long time. So let's just keep using this.
It's very much what we're doing right now.
Absolutely, making an easy thing hard.
It's like yak shaving with less direction.
Exactly. So a question from Carlos, there's no UI for this. If you're using the S3 backends, you don't have a UI. If you're using the Pulumi SaaS, you do have a UI. Has all the things like audit logs that Joe 2 mentioned, other Joe mentioned. The operator logs are obviously there as a resource, and you can also access the S3 state directly and all that kind of stuff.
And it's live updating, so you'll see the actual logs spitting out in real time. It's beautiful. You should give it a try.
Yes. And then I want to know if it's GitOp, if it watches the Git repo. It does indeed. You'll notice that when we define the stacks custom resource, it tracks a specific Git reference. So in this particular case, we are tracking the main branch rather than a specific Git repo. A specific Git commit. But of course, you could update the reference to just be a tag or to be a Git commit hash. And so what it's going to do is just pull down that Git reference and reconcile on that. How long does it track? What's the default, Vivek? It's every 5 minutes or something?
I think it's every minute, if I remember correctly.
Every minute. But it is configurable like most other operators. You can configure the reconcile timeout. Can it handle a Git webhook? I'm going to leave that one to you, Vivek.
No, at the moment it does not. That was one of the things that we were considering how we wanted to do the tracking. We're kind of relying on just native Git at the moment, not relying necessarily on a webhook model essentially. it's all a question of like how much it would all come down to what users really want to do, right? Like some of these live in disconnected networks and things of that nature. Like the operator is not be able to take a Git hook essentially. So doing a polling mechanism seemed like the safest way to do sort of simple Git tracking, but at the same time most applicable across different environments. But certainly, it's all open source, so very happy to take a contribution if anybody's interested in adding it.
So just an addendum to that, if you want a Pulumi program that tracks a Git webhook, you can feel free to build one in the automation API. You would build a web server that takes a webhook from Git, and then when you receive that Git webhook, you can trigger a run with the automation API. We don't currently have that, but I'm now tempted to put one together because it doesn't seem like it would be that difficult. And then the next question is does this replace Crossplane? Without getting into the competitive landscape of infrastructure as code, Pulumi has a lot more provider support, supports languages that you would normally use in your application development lifecycle. So instead of having to define everything in configuration languages like YAML, you can define things in actual programming languages that you use for all your application development lifecycle. So if you are watching along and you have used TypeScript to build a front-end application, you can use exactly the same language. A lot of what we're doing here is in the same domain as Crossplane, but we have, I think we're up to 65 providers off the top of my head. I can't remember exactly how many, but yeah, it's competitive with Crossplane at this point.
But I think the interesting thing is the programming model. Like that for us is where we get really excited. Like the fact that you can build a little Go program that actually does infrastructure as code as part of how the program works, like our operator itself, is really exciting. The deployment engine and the deployment technology is one side of it, but the programming model is completely different. And I think you're not going to see as much of that today because we're focused on the low-level mechanics of the operator. But that's what Joe's flashing on the screen right now, for example, is a good example of that.
So did we get a working operator, Joe, now that we had that interlude of us answering questions?
I got stuck on something else, but
Okay.
I think this actually is some of the things that I think people are likely to hit if they use this. So what we got here is that we're running this. So first of all, okay, and I think this is just, feedback here is that we ran this thing and the status says, last update attempt, and it failed. Mm-hmm. Right. So I think there's this question of, okay, if it failed, how did it fail? What happened? I think,
Could you try a describe on that? You should be able to see it.
Okay. Does it pull?
Yeah.
Without the YAML as well.
I know I got it this time.
So it's basically telling you this is the equivalent of whatever Pulumi CLI, what this would have showed up.
Oh, nice. Okay.
Pulumi CLI, basically.
So your guys are pulling. Okay. So here, let me reduce the screen here a little bit. So it failed because what it's saying is that it's trying to actually create the namespace, and the service account that we gave this thing doesn't have access to create a namespace. And so this is what we were talking about, is that okay, so let's talk about the program that we're trying to run here real quick. So yes. The stack that we're trying to run is coming from this Git repo. This Git repo here is this Git repo is trying to create a namespace in the local Kubernetes cluster. And from there, it's actually using this module called KatesDB, which is in a separate file, to create a WordPress database, and then it's creating a WordPress instance based on that database. So Carlos is asking, that describe was actually, it wasn't events, it was, I think, standard. I don't know. What is the describe here doing?
So if you actually go up, it should show up as like a failure event, and that is like the actual.
Okay, so these are events that are these are events that are getting put in there. Okay. Yes. Yeah. Now, if I'm running with the Pulumi backend, does it actually upload the runs from the operator into the Pulumi backend? Okay, so that's something that I would get, and I may be able to, like, if I wanted to. So that's one of the things that sort of affordances you get if you're using the SaaS backend.
So you should be able to go in here now, go into this Pulumi directory, go into stacks, and you should see a stack per
So this is the stack. And if I open this file, this ends up being, this is essentially the state file that we have here.
Yes. So there's two ways I can think of to fix this problem. We can either update the role to allow it, make it a cluster role and allow it to create resources, or I can very quickly commit a change to this repository in which we do everything in the default namespace.
Well, I guess my other question then would be, is there a possibility for me to, just like I can specify the AWS credentials I want to use on a per stack basis, can I specify, hey, use this other Kubernetes service account to actually execute as the execution context for this thing?
I don't think we do, but that's a great point. I think we should be able to do that. That's a pretty straightforward thing for us to consider.
Yeah, and I think these things always get stuck when you're talking about permissions, because you're like the operator's acting as one set of credentials to do something, right? And then you have, so like same thing with AWS is that you may have one set of credentials for accessing your state file and to access the KMS, and you may want another set of credentials that you're using to actually execute the graph, right? And so there's sort of two sides of that coin there that I think are interesting for sure.
And I think we can define a new service account that will have cluster admin credentials and pass it to the deployment pod. I think that's probably going to take longer, maybe.
Let's do kube control. We're going to add create cluster role binding cluster role equals what is it? Is it admin, cluster admin?
Cluster dash admin, if I recall.
Cluster admin, and we need service account equals and what do we call it? Namespace overview. I forget what we called it. Service account. Pulumi Kubernetes Operator is the name of the service account. Oh. Kate's or SA ugly stick.
I would have called it YOLO.
Oh, service account must be, yeah. This is definitely hitting something with the ugly stick, right? It's like, make it work, right?
Yes.
Give it cluster admin, right?
Yeah.
That's what we're doing. All right. So now we've gone ahead and we've done that. Now what it'll retry automatically, because like I think this is one of the interesting things that's happening with the operator here. Most of the time, the only time Pulumi does anything is when you call Pulumi up via some mechanism. And so that is like part and parcel of any tools of this class, whether we're talking like older school stuff like Puppet and Chef or Terraform or what have you. It's sort of like it's one shot type of thing. Whereas Kubernetes, the whole idea of Kubernetes is continuous background reconciliation. We're always driving towards a desired state. And so this sort of like bridges that gap by automatically retrying things.
And it's a very natural fit too, because the whole idea of infrastructure as code is that you have this goal state, this eventual consistency of your infrastructure, but you're right, you have to manually trigger it. So kind of the marriage of infrastructure as code and the operator is actually a really nice fit. Actually, that's why this worked so well.
Will this try again without?
It's probably in the back off loop now. It's probably
So one of the things is that, especially if this is, I mean, in some ways this is seen as like, user error, essentially, like this stack we tried and we failed and it's reached a terminal state.
Okay, so it's in a sort of a permanent failure.
Right, it has reached that state, and so now in theory, like one thing we could do is like kick the stack in some form, like make a configuration change there.
Yeah.
Or like, but as far as like the operator is concerned, it's kind of thought that this is like I mean, I could keep trying it, but like this is like a failed state essentially.
Okay. I think, one thing that might be helpful here is adopting some of the condition pattern to actually represent sort of where this thing is at, right? More metadata about here's the last time I ran, here's the state, there's a bunch of conventions. This is all coming from the Knative world around sort of the conditions. And I think if there's a bit of an effort to have everybody align their CRDs with a set of conditions, which then allows tooling to be able to represent and show those conditions in a good way. Okay, this thing is Why are we not deleting?
Because it's trying to destroy the stack while you're because of the destroying, like delete and whatever, destroy on deletion side of things that we.
Yeah, okay, it's deleting the resources behind, so there's a finalizer that's probably waiting.
Okay, finalizers can be dangerous like that, because I think what's probably happening here is that because we're in an error state, it's not able to delete.
I'm not sure.
So an IO error occurred. Well, okay, so we had that. That was 11 minutes ago. Okay, so 4 minutes ago, we have new commit detected. So we're not actually seeing. I
believe if you restart the operator pod, it should get you into a better state, right, Vivek?
Let's go through. Oh, you're on mute, Vivek.
Sorry, yeah, I was talking all the time. Okay, sorry. You could either remove the finalizer from the stack, or you could, like you said, kill and restart the operator.
We'll remove the finalizer.
Yeah.
Did that work? I don't know. Maybe. All right, so that did it. Okay, so now we'll apply. All right. Okay, let's see. This thing is here. Do we have a... We don't have a status yet, so something is going on here. Let's look at the pod. The logs here. No logs for the pod.
Huh. Is it failing to start because of a service account problem?
No, it's running. I didn't change the... I didn't... All containers...
It may not be the right way to do this, but I usually kick the pod in situations like
this.
I
know.
I usually just restart the operator pod.
Is that what we did? Oh, sorry, I was under.
We removed the stack, but we didn't restart the actual reconcile loop.
Got it.
Yeah.
So we should get a new pod any minute that picks up the new stack. Because I think we're using the default operator configuration, so it's probably in a back off because it's failed so many times. So it isn't even reconciling at this point. There you go.
So this thing is...
It should take a minute or so to require.
Oh, so it's doing a graceful shutdown, and it's nice you guys do the leader election using the
it uses the config map.
Config map as a lock. Sweet.
Yeah.
Okay. Yeah, being able to have a built-in way to do leader election is actually kind of nice. All right. So one of the things I think, I'll start, I'll give you guys some impressions here. So I think it would be interesting to think about how do we actually use this to create sort of an infrastructure vending machine? Because right now the idea here is that, somebody can activate Pulumi here, but there's no opportunity. You probably could do something using like an admission controller or OPA or something like that, but there's not a lot of support for being able to, lock down what people can do. And so I think, one of the interesting things here is that could we combine this with could you actually say I want a new stack template? And the stack template then is a combination of a pointer towards the program with the inputs, the config inputs. And then you maybe, and so the stack template is something that actually, and then you can have a stack instance that's based on a stack template or something like that, right? And so the stack instance then, and so what you could then conceivably have is the stack template being in some sort of privileged namespace, but then have other namespaces be able to create stack instances. And via RBAC, they can only modify the parameters that are coming in there. The next step after that would be able to create new CRDs that are essentially aliases or map to stack instances. And so then you could say, give me a new WordPress instance, and you don't even know that you're using Pulumi under the covers to be able to implement that. Give me the new WordPress instance. And so these things are like, could be built on top of what you have here right now, but starting to think about those sort of cross namespace roles and that sort of infrastructure vending machine point of view. That's something that I think, we definitely see a lot of usage of in enterprises, right? And now what you could do is you could say like, well, I can now use Kubernetes as my system of record for being able to manage a whole bunch of configuration across clouds. And this is the type of thing that you see people do a lot with things like CloudFormation on the AWS world. So I don't know, is that something that you've all been looking at?
Yeah, for sure. We actually just launched a registry recently, and the registry is actually a collection of all of our providers, but also off-the-shelf components for common patterns, reference architectures, or as you were saying, like kind of templates. We're working on a private registry, so if you're an enterprise, you can have your own set of blueprints. Like we work with a lot of folks who have standard architectures that they just want to stamp out lots of instances of, kind of to your point. And so it actually is really, really good fit for that. You kind of mentioned OPA as well, and policy, and we actually have a policy as code angle as well. So if you want to make sure people aren't violating cost policies or compliance or whatever, you can integrate there as well, and that works with all these sort of components and templates also. So absolutely, we're just sort of scratching the surface. As you said, we sort of have the foundation. Where it gets interesting now is what are those reference architectures? What are those templates? But right now you can build them on your own, but we're hoping to have a lot more kind of out of the box soon.
The default back off, the await period is like 300 seconds, like 5 minutes at the moment, which is probably why the
yeah, because this thing's looking pretty wedged right now.
Yeah, it's actually killed it, but like the termination window, whatever, is like set to 300 seconds.
Yeah,
so it take like
it's still getting itself killed.
Yeah, I mean, what you could do is like basically force kill the deployment.
Grace period equals 0 -- force, like the real.
I don't have that command. Okay, so how do we do this? Delete pod. Is there a way to sort of say again,
so the grace period is
grace period equals 0
-- force.
Force, yeah.
And I think it's gone.
Yeah. All right. Yeah, we're gone. Okay.
Yeah. So it will take just a little bit more time for it to.
Yeah, they just got to acquire the lease. Yeah.
Yeah. The joys of doing this live.
No, but I think a lot of people enjoy this about TGIK because like this is the type of stuff where this is how you pick up all the little tips and tricks and sort of like what works and what doesn't work and what happens if you hit this hit these things in reality. Yeah.
Yeah. So this is actually one of the side effects of like kind of force like destroying things halfway. Like so the stack currently, like the state of the stack, it's saying that there were some things that were set to be terminated, and it basically Pulumi by default tries to be safe about like destroying or like vegging on things that are currently in progress, basically. So yeah, it's trying.
If we just create another stack object, it will just create a new stack.
Yeah. So let's do that. Let's call this. We're going to call it demo 2.
Yeah.
And you would need to change the stack name as well, so the actual path.
S3 backend 2. So we'll do that.
Yeah.
Sure.
So for those following along at home, the reason that this is actually happening is if you provision something with Pulumi and Pulumi can't verify that that API operation succeeded or not, it will tell you that it has something called pending operations in process. If you use other infrastructure as code tools, this is a common thing in which, the API, you have a flaky network or, your access to that API doesn't work. Lots of different reasons why this might happen. And so what you have to do within Pulumi is actually say which of of those pending operations have completed and which haven't completed. So what you would normally do is go into the console, look at all the different parts of the stack that have succeeded and which haven't succeeded, reconcile those manually. We are actually working or like looking at a process of doing this automatically, being able to reconcile those things, and then it would work. But it looks like, as I've been kind of filling the time, it looks like the operator is now provisioning, is actually provisioning lots of different resources in the background now that we have cluster admin.
Here we have, it's working. Well, we're doing kind, so we're not going to get a database out of it, but like we can. Oh, what did I do wrong here? Oh, that's the database.
Yes.
So it's this one here. Yeah, I was trying to talk HTTP to MySQL, and it did not like it. So I can start a port forward there, theoretically. Maybe.
And so remind me, the program is using an AWS database. Is that the idea?
No, currently it's using a local database, but in the next step, we will be changing the database to an AWS database. So right now
we have a dev instance up and running. Everything looks great.
Yeah.
Very cool. I can set up WordPress and everything.
So now that we've provisioned that main branch, if you go and take a look in the actual Git repository, I can kind of talk you through what the changes will be here. So right now, if you look in the main in the index.ts, we'll just talk about what we've currently provisioned. We have a namespace, obviously, which is pretty familiar if you're used to the kind of YAML and Kubernetes interface. And then we have a Pulumi component resource in which we've provisioned a MySQL database. Obviously, this is not going to do as much good in production because this is a temporary MySQL database. If we restart this pod, we don't have any persistent storage. And then we also have a component resource. You can think of these as reusable pieces of infrastructure as code. And so we've provided a WordPress instance to talk to that database. However, we've
WordPress, and so this pulls together a whole bunch of stuff. Okay, cool.
Yeah, and you can see there's lots of best practices implemented in this particular component. So like, I'm only providing the inputs that you might actually want to configure in WordPress. So you don't want to mess around with the ports because you know what port it's going to run on and all that kind of stuff. So what we can do now is we can create a third stack in which if you take a look at the production branch, what we can do is if you look at the rds.ts, there's a bunch of different parts.
So let's look at the index again. So now, instead of actually allocating the database on cluster, we're actually doing RDS, right?
Yes, and you can notice like I can actually pass the outputs of that creation directly to my Kubernetes cluster, my WordPress resource. So we're going to create a manual random, we're going to create a random password for the database. We're going to be able to use that within Pulumi, pass that to the RDS database. I've called it Scary Database because it's going to have to be open to the public for this demo because you're using Kind locally. If you were doing this in production, you would use something like EKS and use a private subnet and all that kind of stuff. But, for the purposes of this demo, we'll call it a Scary Database. And then I can actually pass the result of that Scary Database to the WordPress instance as an output. I don't have to switch between tools. I don't have to switch between, manually pass anything. And if I make any changes and those values update, Pulumi will reconcile them. So all we would need to do now is update our stack deployment to point to the production branch as a reference, and it should update everything.
I'm going to call this one prod.
Well, you can do one of two things. You can create a prod one, or you can just update the reference and watch Pulumi reconcile the whole thing. It's totally up to you.
Okay, so I can do.
I would recommend creating a separate stack just so it's better for you that it's going to take a while for RDS to come up and we're going to have not.
Well, I think one of the problems. So let me look, because are we going to hit if I look at, so we're in the WordPress namespace. Okay, so you append sort of random identifiers at the end of things regardless.
Yeah, you can. So not the namespace. If you go back to the code real quick, I'll show you how you would for Kubernetes at least. You can manually specify those values. So if you look at the namespace, we've got metadata name there for WordPress.
So now you're actually saying don't generate a name. I want to actually name the thing. And so.
The reason we add those random IDs to the end of every resource is if you've used most cloud providers, they have lots and lots of immutable APIs in which you can't do a patch operation. In order to actually change that resource, you need to kind of create a complete replacement. And so the random IDs allow you to do like blue-green deployments, and Pulumi will automatically create the replacement, add it behind the load balancer, update it, and everything will happen. And it happens in the right order.
Yeah, so we're not going to hit any issues if we deploy another stack into the same namespace with this stuff.
No, but I'm with Vivek. We've had enough. I've had enough heart attacks in the last 20 minutes, so I think a third stack would be a good way to.
All right, we'll do that.
Do this.
The only thing might be because we're hard-coding the namespace to be WordPress. I don't know if you'll.
That's what I was checking on. So
that's the one that I think we might get a collision on.
That should be okay, because I would assume that like this thing, like if WordPress already exists, it's like, oh well, right. Well, make it upset because it may not like that it can't delete it after the fact. It may be like, hey, this thing.
Yeah, you're gonna have.
I vote for living on the edge for what it's worth.
Yeah, I'm with. I think you're actually right because I've used the same namespace in both of these examples.
Mm-hmm.
I would just update the current.
Okay,
stack.
so we won't do a new stack. Well,
let's live on the edge. Yeah, okay. Let's. I'm with you.
That has to be -2 at the bottom, didn't it?
Did I? Oh, yes, -2. Yeah. Okay. Yeah. Let's let me look to see what our current state in the cluster here is, just to.
I just want to address Juka. Yes, I am very aware that MySQL instance is not the way to do it. It's called a scary database for a reason. It's mainly to facilitate the demonstration. I would not be advocating for this in most situations. And what I'll do after this is finished is I'll go and make this a proper production level database with an EKS cluster and all that kind of stuff. So that, and if anybody watches the stream, they can come along and see what it looks like.
Okay, yeah, and we usually check in these notes. I'll probably do it sometime this weekend or next week into a GitHub repo to live long term, and so so everybody can. And if you want to update that stuff, we can keep that up to date.
Yes, absolutely.
All right, so now this thing is configured and it's actually supposedly running. So if we look at the new last seen, new commit detected. So it's going to. Oh, it says failed. So what did we fail? What did I do wrong?
I think you put the wrong branch in. I think it was like prod, was it, or production? Sorry, I don't remember.
I think it is production.
Is it production? Okay, got it.
Heads production, right?
Let me double check.
It was production. Sorry, never mind. I thought it was production.
Okay, that's what I thought I had.
So
I must have screwed something. Let's go and look at the logs for the operator and see.
Or if you, I mean, the logs may have like stack traces may not be super useful, but you should be able to again look at the events and see.
Okay. So we'll do the.
Okay.
There are WordPress namespace. WordPress already exists. Are we sure we're targeting the right stack? Because it's trying to create a second namespace. It's trying to create all new resources in that stack.
So something happened at some point, and man, yeah, I'm sorry, guys. I
think it's targeting the wrong stack at the moment.
So which of these succeeded? So here's the one that like.
That's the old.
The old one that failed.
That's right. So now let's take a look at the.
Here's the one that.
If you look at the, just look at the stack resource itself, like with the YAML, that might tell you.
That says it's failed also. It did succeed at some point, so I'm kind of confused.
Right. So the change. So it looks like it's trying to apply the. You have the Pulumi State. You have the branch. Deceased. Interesting. Did we? Let's see if there's any more updates. Like, did we by any chance do the S3 backend without the -2 before, and somehow?
I don't think I did, but yeah, I'm not sure what's going on here. Let's do this. Let me go through and all right, so here's what we're going to do. I'm going to go through and I'm going to nuke the S3 bucket.
You could delete all the stacks, I guess.
I think I can just delete the stacks here, right?
I would delete the JSON file rather than the directory.
Okay. So let's delete this and this.
If you do this, you're going to have to delete the namespace.
Yeah.
Manually. Yeah.
So delete the objects there. And then cube control, delete.
I guess we could have just done a regular deletion of the stack or like the stack resource. That should have cleaned things up as well. Anyway.
Deleting namespaces is always slow.
It's got to do that cascade, right?
Yeah. All right. Looks like it's gone. Okay. So now we have this. Let's delete. Maybe we can delete that one. It's kind of half deleted. Oh, I think these things are fighting now.
Yeah.
That sounds that we're running the same program in two separate stacks in the same cluster.
Yeah. So what is the delete?
Easiest would be to get rid of the finalizer on the stacks, delete that, and then delete the.
Oh, it's the finalizer that's hitting us this time, right? Yeah. Oh no, it's gone. Okay. So it eventually pulled its act together and was able to delete. Okay.
Thank goodness for Octane, huh? This is super helpful.
All right. So I see something new. Unable to check out branch reference not found. Interesting. So let's make sure that.
Are we passing the right reference?
Head refs heads. Make sure.
Is that the right branch? I'm always get confused on how you specify branch.
Refs heads and then whatever the name of the branch is.
Refs heads and then production.
Right. That should be right. And then is the repository, like the repository we didn't change?
No.
Interesting.
So let's look.
You could use the SHA hash, I guess.
The SHA hash is a pretty good idea.
Yeah, you could just use the commit directly.
So here, delete the original stack. We create the AWS secret. We had that. Oh, did we not have region?
No, that's fine. It doesn't care about that.
It's not finding the actual branch. For
yeah,
reason.
That's where we're failing, and I'm wondering why.
You can see that I had this working with that exact YAML earlier, so I'm confused as to why that isn't working either.
Let's delete it.
It's not like fat finger by any chance, right? Just make sure that the production is spelled correctly. Okay, cool. Sounds good.
I would
just use the commit directly, so you can actually
I would use
replace the branch with a commit, and that will do a specific commit. So the commit to pick would be
this commit. So how do I specify the commit in this? This is the syntax. So would it be branch or commit or what?
No, just the SHA. You could just specify the hash. So just commit, like replace branch with commit, and then just the actual SHA that you got.
There we go.
All right. So I was trying to delete the thing, and so now we're stuck on finalizers again. Finalizers are always troublesome like this because, like, if the controller gets a little confused on stuff, then hilarity ensues.
The irony is, you probably came up with the idea of finalizers, didn't you?
I don't think that was me. I mean, like, in any GC language, finalizer is always a pain in the butt too, right, Joe?
Oh yeah, absolutely.
Nobody likes finalizers in any supply.
Actually, the source of a lot of security problems in .NET, at least.
Yeah, for those who don't know, Joe has a long history doing .NET stuff back.
I cannot escape my past.
Yeah. All right. So now
I'm going to be honest, Joe. I nearly wrote all this stack in VB.NET, but I thought that the people would immediately log off. So
Lee loves writing infrastructure as code in Visual Basic. I cannot explain it, but it's quite endearing.
It makes me feel like I'm from an older time, Joe. That's what it is.
All right. What are we getting here? This looks like a stack here. Failed to create local workspace. Unable to enlist Git repo. Reference not found. So it's really not happy about.
Did I push this?
Branch. Auto set Git. I don't know. Did I like typo something else?
Did the name of the repo change somehow? No?
I don't think so. Let's follow the link here. No, that gets us there. We have the commit. Reconciler error, TGIK demo 2, namespace default. Failed to create local workspace, failed to create workspace, unable to enlist in Git repo, unable to check out branch reference not found. Is there could there maybe some bug where it's actually, we're getting some contamination from one run to the other?
I can't see why that would be, but I have been wrong before.
Telling me the.
Did we make sure that there's only, like, now there's only one stack at the moment, right? Like, we make sure of that.
Yeah, home runner work.
Yeah, I mean, it's not.
Yeah, we only have one going right now.
Got it. And did it
let's
actually?
Let's just on the interest of trying to actually get this done, let's delete.
I mean, what it can do is just merge the production branch into main, and that will almost certainly.
Well, I mean, like something's going wrong here.
Something's wedged here, so I don't quite understand what's going on here.
So let's restart the pod.
Right.
I thought I copied that pod. Maybe that'll work. Oh. What did I do wrong?
What are you trying to do? Are you
trying applying a pod name?
Oh shoot! I actually put it in the wrong.
Right.
I wanted to do this. There we go. Sorry about that. Okay, force deleted. Okay, pods. Now this one's up and running.
Mm-hmm.
The logs here. It's trying to get the agent, custom resources to stack.
Let's make sure that is correct on there.
That's left over from last time.
Right.
Last updated. So does that mean it worked? I think that means it worked.
Yeah. So it's
it's in the middle of actually reconciling. Yeah. So it created the namespace. And
so the RDS
now
provisioning,
it's in the process of waiting for AWS to get its act together.
So you should be able to go in here and go into RDS, and you should see a database being created.
Maybe. Come on, AWS.
I'm going to blame US East 1 for all of these problems.
That's right.
It's all US East 1.
There we go. Look at that.
So there's a couple things that I want to talk you through while we wait for this RDS instance to. So if you go into the actual stack, into the S3 bucket, there's something that I think is interesting to note.
Okay.
So if you drill down all the way into the stack itself, and so you can go into here, you can go into the Pulumi folder, you can go into the stack, you can go into the stack JSON. I think it's that one, right?
Yeah.
And then actually look at the actual here. So you should be able to Control F and search for password, and it's a bit small, so I can't actually see at the moment, unfortunately. There we go, much better. So what we've done here is we've generated a random password, and then we've passed that through to the Kubernetes pod.
Okay.
But something I think is interesting about the Pulumi support is if you keep scrolling down here, you should be able to see that in lots of other infrastructure as code tools, the password itself is stored in the state file. And so your state file becomes kind of the most scary part of your infrastructure.
Because you're storing secrets in there. Okay.
Exactly. However, when we specified when that KMS key, when we started up the actual stack itself, we encrypted that password.
Gotcha. So this is just a reference. This is not the secret. It's just a reference to the secret.
So no, the secret is in there, but it is encrypted, and I can't remember what the value.
Oh, I see. Okay, so
here it is. So you see ciphertext. So you see the
so we have ciphertext here. Okay. And then this uses your secret encryptor to be able to do that stuff. Okay, gotcha.
So it's using the KMS key that you've specified in the stack to actually encrypt that value. And so you no longer have to kind of worry. And this is a great value proposition when it comes to the Pulumi SaaS as well. Like one of the things that people say to us is we'd love to use your SaaS, but we don't want to give all of our database passwords to you and give all of our API keys to you. And we just say the same thing. Like you can just pass a single command line flag in your own KMS key, and we can't actually view them at all. So it's all stored in an encrypted manner. Obviously, the secret itself in the Kubernetes cluster is encrypted by whatever the Kubernetes cluster would use. So, you know, if you're using encrypted etcd and all that kind of stuff, that's there. But I think this is really useful because what's happening on the inside the operator is the operator is making a call to AWS KMS when it's doing its run, decrypting that value with the KMS key, and then provisioning the actual resources.
So it never leaves your firewall. The secret never leaves your firewall.
It never leaves your security boundary. And the operator itself, despite all of the kind of teething issues that we've had so far, the operator itself is just a great mechanism of doing continuous delivery within your security boundary. And so you never have to worry about those kind of things. We can quickly go through one of the things that I also think is interesting as well is that Joe talked earlier about this difference between imperative and declarative. In the actual Pulumi program, the secret itself has been created and the RDS database has been created. But you'll notice in the actual code itself, if you go into the index.ts, in here, you'll notice that we're creating a scary database, and that has a bunch of what we call in Pulumi outputs.
Right.
And so that's the result of the API call to AWS when you create a database. And Pulumi knows that because we're passing the output from a scary database to our WordPress instance, that means that Pulumi knows to create those things in order. So everybody will always say, well, what about the difference between imperative and declarative? Because we're passing outputs from one resource to inputs of another resource, it knows the order in which to create things. And because the secret itself isn't being passed to anything else, the secret is ready to be created. So it will do things in parallel. It will do things much quicker. All we're really doing now is waiting for Amazon to create a database for us. And shortly after that, we should get a deployment and a Kubernetes service and all the other things that we need.
Okay. So essentially the model is that you run this program, it generates essentially an execution graph. And one of the items in the execution graph is create a secret for me, and then pass that secret around. But the program, this thing runs, it's already done and completed running this program. Now the Pulumi execution engine is actually going through and actually executing sort of the results of the program to make stuff work. Okay.
Yeah, it's essentially a DAG, right? It's a DAG, and all these outputs form the edges between nodes in the graph. And it's actually really cool because this is where background in programming languages was actually helpful to build in Pulumi, because these are essentially promises, right? But building on Lee's point, the secrets understanding, the engine understands secrets in a deep way. So transitively, we can encrypt anything that secret touches. So you really can be sure it's not going to leak the secret.
Another failure. I feel like this entire day has been a failure at this point. What is the error?
It's saying that I don't know if you can read this.
Pending operation, it looks like, or an unknown state, because
it wasn't able to confirm that the database was created. So did something get in a, so this is
enable list and then fail to update.
Yeah, so this is something where like when you get into this sort of like wacky state here, having some guidance on how
it's
to...
again throwing us another error around the namespace already existing.
No, I don't think that's what was going on.
Is that an old log? That's an old log.
Yeah, because we're dealing with the same stack essentially. Yeah, so I mean, for some reason, like the perhaps before it tried to do, like we didn't get rid of the state, I guess, right? Like it had tried to.
I thought I did get rid of the state, but
maybe we interrupted it while, like, when we were cleaning up. It was actually trying.
Maybe something got interrupted,
and then we nuked everything from underneath it, and now that's why like messing with.
It actually was provisioning the RDS database.
Yeah.
Yeah.
So we do. I mean, we have a database up and running now.
So that might have been from the previous attempt at like provisioning the database.
Are we sure we're not looking at an old log entry?
Well, I would have expected the WordPress deployment to have completed by now.
Does that not depend upon the database? Or?
Yeah, but the database had finished creating and is active at this point.
Yeah, so there are certain things we can do to sort of refresh this. But yeah, I mean.
Yeah. Okay. So I think, we got the data. So I think what happened here is that we were, we got stuck and we tried to hack our way out of it, and we had some concurrent stuff going on, and that caused us some problems here. So let's give it one more try here. What I'm going to go ahead and do is I'm going to go through and let me see if I can repair some stuff. We're going to go through and we're going to delete the okay.
What I would do here is I would start with deleting the stack with a for.
Yes. So we're going to delete the stack.
Start with the stack. Yeah.
Okay, we'll go to Octane here and we'll look at custom resources, this stack here. We will remove the finalizer out of it because that's probably going to break it because it won't know how to like get stuck.
Well, what it will do is it will wait until RDS returns a deletion operation. And I think one of the things that we talked about when we were putting this demo together is RDS a good a good way of showing this. And I think we wanted to really see if we could show the actual way that you would do this with an actual application. But RDS can often take between 3 to 5 minutes. So we may have kicked the pod while it was deploying or something along.
Yeah,
those lines.
I think yeah, there were some sort of like weird concurrency things going on because we were mucking with things behind the scenes here. Okay, so now we've deleted the stack. I'm going to delete the state file here.
I've been advocating for a while, and I'm going to advocate it again. We should have a Pulumi stack pending operations. Yes, they're okay. I'm really sure flag, which is basically, I know my RDS database provision correctly. The current way of doing it is that you would actually kind of modify the state itself and remove those pending operations. And we have got some UI improvements for the CLI in place to actually, in proposal to actually make that a little bit easier. And again, it's mainly a safety mechanism, right? It's what Pulumi's telling you is, I don't know what happened when I created this database, and I really don't want to screw it up. So can you verify that these pending operations actually succeeded? Because otherwise you could end it with accidental database deletions and production outages. So those pending operations are just a gate for you to say, make sure that this is actually finished, basically.
Yeah. And I think this is this is a good lesson, is that automation like this is essentially a space laser. And if you're not careful, you can have collateral damage, right? You can actually delete stuff without recognizing that you're deleting it. And so, and you can do it at scale, right?
It's absolutely.
At scale using this type of stuff.
It's interesting because we do have we have quite a few customers using this operator. Some very large companies that I won't name that you would certainly have heard of using this operator at a production, in a production capacity, and provisioning really large numbers of resources. And so the joys of a live demo.
Yeah, I'm sorry, I tickled something wrong here. Okay, so here's what I did: is I just to be clear, so I deleted the stacks and the CRDs for the stacks. I then deleted the state files, and then I deleted the namespace, and then I restarted the pod. So I think, we should be sort of as reset as we're going to get reset here.
Yeah,
I might append a 3 to the stack name just to be safe.
I would also check. I would also just double check that there are no other namespaces in the actual cluster, like the WordPress. Because I think what happened there is that we didn't delete the WordPress. I think it's tried to create another WordPress namespace. So just double check that.
I think we're good. So no other namespaces here, and I did do the 3 thing. Cube control apply-f, and we had my first stack .yaml. Okay. And we can look at the YAML, and it hasn't been picked up yet.
And the operator is running, just to make sure.
Yeah, I'll check that next. Okay. Oh, it says it's running.
Okay.
And so now we should see a new WordPress database.
I think you need to refresh.
Trying to refresh it. Yeah. Okay, so this one's deleting, so it hasn't gotten to.
And the auto naming is going to really help us here because otherwise it would try and create a database called WordPress that already existed, and it would run into an issue again. And so any minute now it should throw up another database.
Unless I have some sort of, if we're hitting a quota thing, I'm just going to call it done. Because that's clearly not y'all. So let's see, and let's look at the pod.
Oh, it's still acquiring a lease.
It just acquired the lease, looks like, or I don't know when it did. But
yeah, it's like 3 minutes ago, so it should be.
Can you look at the events? Just to be sure.
Yeah. It should have showed us events.
Yeah.
And so, conditions, no conditions. There's no. It shows events here usually.
Right. Can I just take a look at the stack again, just to be sure? Like this.
Yeah. So no status. I mean, so somebody updated the status and at least put last update in there.
Right. So
let's look at the log.
Did we have the commit as well? Oh, we do have the commit. Okay.
Yeah.
Yeah.
Okay.
I don't know, man.
We just restarted the pod too, right?
Yeah. So this is doing a Pulumi up.
That's right. So it's doing its thing. It's in the middle of doing a Pulumi up at the moment. This is one of the things that would be nice if you were using like the production, rather the Pulumi backend, is like you would be able to see the status of what's going on.
Okay, we'd have some more.
Yeah.
So here's 3. Yeah, I mean, if given enough sort of like elbow grease, you could decode this, right? But like.
No.
So it is creating resources. There are resources being created.
Yeah. So maybe it's just. Oh, there it is.
There it is.
It's creating it. Okay.
I bet this was just AWS's API not valuing our time as it
that's
so often does.
That's probably what's going on there. Okay. So now if we go to the custom resource here.
And is it set up, Lee, such that the RDS database has to be created first because the other things depend on it?
Yes, because we're passing the outputs from the RDS database to the WordPress deployment. The namespace should exist and the secret should exist now, because they don't have any. Those outputs don't have any dependencies. So the namespace, there it is. That's one WordPress native namespace, and there should be. That's the password that's going to get stored. That's been used by the random. By the random provider has been created.
Yep, there's our password, base64 encoded for your protection.
Somebody wants to type that out and base64 encode it, they can go right ahead.
But you still don't know the address to connect to. That's going to come later.
Yes, but so like again, the way Pulumi works is that if you go into the RDS management tab right now, and if you go into the actual creating database, there's a bunch of properties here like endpoint, port, all those different things that eventually the AWS API will return to the Pulumi provider and say, okay, this is now finished completing. This is now finished creating. Now that we know the endpoint, I can pass that endpoint to a new resource and I can start creating that. And that's again how Pulumi's DAG works. And that allows you to, do things in a specific order. Obviously, we're going to have to wait for the database to get created. Usually takes about 3 or 4 minutes.
But I think we're on Rails now.
Yes.
Famous last words.
Right.
Yeah, I think that's the setup time and getting this thing, installed and ready to go. I think it's a little bit more smooth sailing from here on out.
Yeah. Well, and we dug into a lot of the details of sort of what was going on here.
Although I'm still mystified by some of the concurrency stuff. I think some things were maybe still running in the background, or maybe it was creating the namespace in parallel with some of the manual.
I do think there's definitely options for us to improve here, right? Like there's definitely things that we can that we can go ahead and make better here, especially around the concurrency. You should be able to see the actual if you do a kubectl describe on the stack. What you should be able to see is on the stack resource. What you should be able to see is the Pulumi automation API's structured output when things go wrong. So like if something goes
right now
wrong,
we don't see anything, so that means that everything is good, right? It's
it's still creating the resource.
No news is good news.
And if you think about how this is working on the back end, it's just polling that API, that RDS API, to say, have you finished creating yet? Have you finished creating yet? And just
all right. So now it's created.
Okay.
So now the
it is showing up as created on the
yes,
it's active here, available. Okay, got it. Okay.
Yes.
Yeah. So we got that there. So now eventually we should see
the
okay.
There we go.
There we go. Okay. So now this is the WordPress, and then the service here is for the WordPress. And if we look at the pod here, what we'll find is, and if we look at the YAML, what we should find is
there you are. So that's the value.
That's the secret ref, and then here's the database name. And
well, I think the interesting one is the DB host, which has been passed directly from the creation of the RDS database to the Kubernetes. So you've
essentially done the dependency injection into the configuration there.
Exactly, and you should be able to open this up with port forward, and it should just be a standard WordPress instance.
And even though the database is open to the internet, at least the password.
At least we have a password.
The password is randomly
We're
generated.
probably not using encryption as we use that password, but woohoo!
Woo!
Look at that.
There we go.
We went the long way around, but we eventually got there.
All right. Well, thanks, guys. I think I'm gonna go ahead and we can go ahead and wrap up. We found our way through. We got it working. Hit a few snags along the way, but I think honestly, I learned so much when things don't go well than when they do. And we were definitely coloring outside the lines a little bit here, I think, in terms of, and I think that the lesson that I got is that if you launch, I think, launch 2 stacks that are trying to actually allocate the same resource without using that resource renaming thing, you got to be really careful about those explicit references versus the sort of the automatically created references. And I think, if you're really buying into Pulumi up and down the stack, then you let Pulumi manage the real names of everything because you don't need stable references outside. I think it probably only hits when you want to map DNS to the outside world, right?
Exactly. Yeah.
So that was it was fun to debug it and go through it. And I'm excited about the idea of actually using Pulumi. Like, one of the things that I think is I think everybody sees the promise of operators in the Kubernetes world. and it's a pain in the butt to write operators. I think some of the stuff that we dealt with here talks to some of that. But a lot of times what we want to do with operators is we want to be like, well, I want to use this operator as essentially a macro to generate a bunch of other Kubernetes resources and manage them, or to create cloud resources and manage them. And so I'm excited of viewing like this as a way to create a special type of operator, right? How can we use Pulumi as an operator toolkit to be able to manage other things on Kubernetes or other things that are happening? So I think that ends up being really interesting and cool to me. So yeah, so thank you so much for joining and showing me how it all works. Any closing words? Anything else that you want to say to folks?
Well, no, I'm sorry. I'll just jump in. Thanks for your patience, Joe. It's been really great to kind of take the town, and I'll let Joe, other Joe, see us out.
Well, I was just gonna thank Lee and Vivek because they prepared all the goods today, and I appreciate they did all the hard work. And well, aside from you, Joe, who
I just show up and fumble around. That's my job.
Whatever word you guys were using from
faffing.
Faffing, yes.
Oh no, it was great. Honestly, I'm excited about some of those opportunities that you were talking about, Joe. The automation API that we talked about earlier. You can literally just write Go and embed these IAC capabilities inside of it, and that works really well with the operator SDK. And so I'm really excited to explore that.
The intersection and the interoperability of these things starts to look really cool, especially like I mentioned things like Cartographer as a way to do this stuff. Other parts of the cloud native ecosystem, I think, like the interaction with like the Flux GitOps toolkit and being able to, be much more explicit about when do I actually want to promote something into being used by a stack. And like, I don't know, I think lots of exciting stuff going on there. So yeah.
Absolutely. And thanks so much for having us. It was
all right. Well, thanks for taking the time. We went a little bit over, I try and keep it to an hour and a half. We did not succeed this time, but thank you everybody who stuck with us either live or watching the replay. I appreciate it. If you watch the replay, I hope you watched it at like 1.5. It's the appropriate speed to watch the replay. And we're going to have folks coming back next week. I don't have the schedule coming up, but I'm going to work to get that posted to the TGIK GitHub repo, and I'll be tweeting about that. So we're getting better about actually planning this stuff. So thanks again to the Pulumi folks for helping us out, and thank you to everybody who joined us, and have a great weekend, everybody.
Thanks a lot.